Yes guys, so let's continue our discussion on stop and wait ARQ. I hope you have understood whatever we have discussed till now. Okay, those were complete basics. Okay, now we are going to use the exact terminologies that are used in stop and wait ARQ. We are going to calculate how much time it is going to take. We are going to talk about transmission time as well as propagation time, which is also known as transmission delay and propagation delay. So all these things would be over here. Okay, now what happens is let's get started. Okay, so let's say again this is my sender, okay, and this is my receiver. I'll write S for sender and R for receiver. Just remember, all the same cases are still there. Okay, now there is some data, okay, that needs to be sent. Okay, but if you remember from from the previous class, that we had something over here, right? Sender was also aware and receiver was also aware that what to expect, and sender knew what to send, receiver knew what to expect. Okay, so how it happens? Okay, there is some phenomena that is known as sequence number. Okay, so basically they do not exactly know, the receiver exactly is not aware of what to receive or what to expect. It knows the sequence number of the data packet or the data frame that it expects. Okay, so when we talk about stop and wait ARQ, okay, the window size for sender and receiver is equals to 1. I hope you remember this thing. Okay, so what happens is, let's say this bit is 0 and this bit is 1. This is the sequence number that I have. So let's keep it 0 and 1. I am not going to enter the rest of the data for the time being. Alright. Now what happens is, sender is going to send what? It is going to obviously send 0. The moment it has this data, the timeout timer starts. Right? We already know this. So sender is able to, let's assume sender is able to send the bit 0 or the sequence number 0. Now the moment receiver has received it, okay, earlier receiver was expecting what? This first one. Now the receiver has received this one, so receiver does what? It slides its window. Okay, it basically slides its window to next one, like this one. Okay, now the receiver expects something. Okay, the receiver is expecting what? The next sequence number. The next sequence number is what? 1. So it would not send acknowledgement for 0, it is sending acknowledgement 1, like this. What it means by this acknowledgement is that I have received whatever you have sent to me, and now I am expecting the sequence number 1. Okay, now what happens at the sender's end? The window would move from 0 to, earlier it was at 0 here, now the window would move from 0 to 1, like this. Cool. Now again what happens? It sends 1. The moment receiver receives that data, it would shift its window, right? It would shift its window to, let's say, at this point, okay, and it would send the acknowledgement. Now the one use case is that both the sender and receiver can have their sequence numbers like this: 0, 1, 2, 3, 4, 5, so on and so forth. But if I am talking from practical point of view, sender and receiver is going to have only window size equals to 1. So instead of having numbers like this, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, so on and so forth, first it can send 0, receiver receives 0 and sends acknowledgement for 1. The moment sender receives acknowledgement for 1, okay, it sends the 1. Okay, so can't I start with 0 and 1 once again? 0 and 1, Can't we do this, right? So over here, okay, to represent this sequence number in memory, we only need what? We only need one bit of information, that's it. You can place 0 or 1 over here, as simple as that. If the sequence number is of lesser bits, obviously the maximum utilization of channel would be there. Okay, alright, got it. Now what happens is, I'll simplify the diagram now. Okay, I'll write sender over here, I'll place my receiver over here. Okay, this is how the sequence numbers looks like: 0 1 0 1 0. Okay, this is at sender end. At receiver's end we have 0 1 0 1 and 0. Okay, so sender sends what? Sender sends 0. Receiver sends acknowledgement for what? Acknowledgement for 1. Okay, don't forget the timeout timer is still here. Even if I am not mentioning it, you should consider it. Okay, then sender sends 1, receiver sends acknowledgement for the next data frame that it expects. Okay, so 0. Sender sends 1, sorry, sender sends 0 as per acknowledgement received. Receiver sends acknowledgement for next one. Sender sends 1 now. Okay, receiver sends acknowledgement for 0. Got it? Now the moment this acknowledgement has been received, sender sends 0, and now we do not need anything, receiver just passes on the acknowledgement, as simple as that. Okay, got it? I hope this thing is clear to you. Alright, now there is some time associated. I hope you understood what we mean by sequence number. Sequence number is basically used to represent the packets or the frames. Okay, so that we just send this data to the receiver, that how many sequence numbers are expected, something like this. Okay, now there are two things that are here. One thing is known as transmission time, second thing is known as propagation time. Okay, it is also known as transmission delay and propagation delay. Right, I hope this thing is clear with you. Okay, I hope there is no doubt till now. Alright, alright. Now first of all, I'll tell you what is transmission time. Okay, I'll just write the formula first and then I'll explain this thing. Okay, so transmission time is nothing but it is the ratio of length of message. Okay, length of what? Length of message divided by bandwidth of channel. Okay, length of message divided by bandwidth of channel, known as transmission time. Okay, propagation time is nothing but distance from sender to receiver divided by propagation speed. Okay, propagation speed. Now what do we mean by these two terms? Okay, what do we mean by these two terms? Okay, just see, I'll discuss one example only from sender to receiver and you will be able to explain every single thing. Okay, let's say this is sender, this is at receiver's end. Okay, obviously at the sender's end, this thing is, you can consider as the device. Okay, and this thing is the device of the receiver. Okay, now the amount of time, and there is channel in between them, right? There is channel in between them. The amount of time, okay, taken by sender. Okay, I'll change the color of this. Yeah. Okay, the amount of time taken by sender to place the first data bit, onto the channel, so that it can be sent to the receiver. Okay? The amount of time taken by the sender to place data onto the channel, okay, is known as transmission time. Time taken for the transmission. Got it? Got it. Then propagation time or propagation delay. It is the time taken for or time taken by a data frame to travel from sender to receiver. So this thing is known as propagation delay. Okay, this thing is known as propagation delay. Now what happens is, if I talk about receiver send, okay, if I talk about receiver send or sender send, the amount of time taken by sender to send the data to the receiver is transmission time plus propagation time. Okay, that is the amount of time taken. Okay, now it is not like that your receiver is free all the time. Receiver must be busy in processing something, correct? Receiver must be busy in processing something, right? So there is some delay. The moment your data packet reaches here at the end of the channel, now let's assume your receiver is busy. Okay, so there is some delay here. This delay is known as queuing delay. Okay, queue delay, I'll mention it. Okay, this delay is known as queuing delay. Okay, the moment now that data or data frame has been received by the receiver after queue delay, okay, it will process that data. The amount of time taken to process data is known as processing delay. Correct? The amount of time taken by your receiver is known as processing delay. Now is it so? No, it is not so, because sender also needs something from the receiver, right? What it needs? Yes, it needs acknowledgement. Okay, it needs acknowledgement. So we usually draw acknowledgement like this, right? Without caring about anything. So if it has sent 0, it is expecting acknowledgement 1. Okay, now when this acknowledgement is there, the amount of time taken by the receiver to place this acknowledgement bit onto the channel, okay, is again known as transmission time of what? Of your acknowledgement. And the amount of time taken to send the acknowledgement from receiver to sender is known as propagation time of what? Acknowledgement. Okay. I hope this whole concept is clear till now, okay, so that I can move now onwards. Okay. So again, transmission time is the amount of time taken to place the first data bit onto the channel from the device. That is transmission time. Propagation time is the amount of time taken by the data frame to travel through the channel from sender to receiver. Okay. Then we have queuing delay. Obviously, it is assumed that your receiver is also busy executing all the other tasks. So the amount of time your data frame waits to get into the receiver's device is known as queuing delay. Then the moment the data frame is received at the receiver's end or receiver's device, now it needs to process that data. Processing delay is also involved. The moment that data has been processed, now they need to do what? They need to send the acknowledgement back. So receiver also needs to place the acknowledgement data frame onto the channel. So that is transmission time of acknowledgement once again. The moment acknowledgement has been placed onto the channel, now it would travel from receiver to sender, also known as what? Okay, now the time taken to travel from receiver to sender is also propagation delay or propagation time of acknowledgement. Okay, so if someone asks you what is the total time involved, I am considering all the factors, guys. Okay, I am considering all the factors. What is the total time? So total time is transmission time first, okay, I'll write numbers over here so that it is easier for you to understand. First, second, third, fourth, fifth and sixth. Transmission time plus propagation time plus queuing delay. I do not know the spelling, guys. Queuing delay. Okay, just take care of this thing. Plus processing delay. Plus transmission time of acknowledgement plus propagation time of acknowledgement. As simple as that. This is how easy things are. Okay. Now this is the overall time. I have concluded all the, or I have used all the factors in this. Sorry, apologies. So I have used all the factors here. Now I have used all the factors here and considered every possible thing. This is the overall total time, okay, involved in the whole process of sending and receiving data. Okay, got it. Now what happens is basically, if you think from examination point of view, sometimes what happens is they do not talk about, or they do not mention these things in your questions, that there is some queuing or processing delay involved. Okay, so sometimes it is not there. So how we can write this thing? Total time is equals to transmission time plus propagation time plus transmission time of acknowledgement plus propagation time of acknowledgement. Okay, considering these things are not there, if they are mentioned in the question, you are supposed to consider them, otherwise it is equivalent to 0. Okay, because these things are quite negligible. Okay, now what happens is if you will see, acknowledgement data frame is a very small data frame. Okay, and the amount of time taken to place that data frame onto the channel from the device is very less, or it is significantly less than this transmission time of the original data frame. So this thing is also negligible. Okay, so eventually your transmission time is nothing but, total time is nothing but transmission time plus propagation time plus propagation time of acknowledgement. Okay, now over here this time would be almost equal, right, because they are traveling from the same channel, it is assumed that. Okay, so we can say that it is transmission time plus 2 times of propagation time. So eventually this is what we have in total time, given that we are ignoring all these factors due to their negligible time or close to 0 time. Okay, I hope this thing is clear with you guys. There is no doubt, I hope. Okay, now there is one more thing. Okay, now there is one more thing which is known as what? It is known as propagation, sorry, it is known as round trip time. Usually this thing is not asked. Okay, but yeah, what is round trip time? In operating system we have already seen, round trip time is nothing but the time taken to go and come back. Okay, and the time taken to go is TP, time taken to come back is TP of acknowledgement. So can I write something like this? Right, so this thing is known as round trip time. Okay, I hope you are able to understood these things. Okay, and they are quite easy to comprehend as well. So if you have any numerical, you just need to place values over here and your job would be done. I hope you are understood with all the concepts, all the basic concepts. Obviously I didn't discuss this thing when I was introducing the topic. The reason being, I didn't want you to confuse with all the terminologies that are there. Okay, that's why I used some of them in the in the past, and now I am using all the terms that are there. Okay, so that's that from this topic. I hope you have understood it.